Welcome to Unit 12, Part 2. First, before we start talking about address translation, let's just talk about the contents of a page table. Your page table could have the frame number. Of course, it needs to know which frame it's in. It could also have a valid bit. This bit would indicate whether that page that is currently in the frame is valid, or maybe instead of, you might have replaced it with another page and so it's no longer valid. So you can use one bit to indicate that. Protection bits, which indicate, you want to put some protections on particular pages, and a modified bit, which indicates whether or not the page has been modified while it was in the frame. And we will talk in more detail about this when we get to page replacement algorithms. So just wanted to give you a quick overview on the contents of a page table. Now let's talk about address translation. So what happens is you have your process which has a virtual address. That means that it has a virtual representation of the process that starts from the beginning and goes and it's the entire process that's broken up into pages. And that has a page number and then a location within the page where the instruction is. And then each logical address is then going to actually be mapped to a real physical address, which indicates the frame that it's in and the location where the instruction is within the frame. Now the offset between the logical address, which has the page number, and the physical address, which has the frame number, the offset is going to be the same, because if you have one particular instruction that's on a page, for example, if you look at here on the letter F, for example, the letter F is going to be on page 1 and it's going to be at offset 1. And if you look in your actual physical memory where the letter F is, that's going to be on the offset is going to be the same. The offset is going to be 1 and it's going to be located on page 6. So if you take a look at this example, this is a very simple example and it's from your book. I just colored it. If you take a look on the left, you have this is one process, and each byte is A, B, C, D, E, F, G, so it's in order alphabet. It doesn't really matter about that, but you can see that it's broken up into 4 pages that are 4 bytes each. So the first byte would be 0000, then 0001. So you can see you have page 0, which has 4 offsets, and you have page 1, which has 4 offsets, and you have page 2, which has 4 offsets, and page 3, which has 4 offsets. And then if you look on the right, you have your physical memory. Your physical memory has been broken up into size 4-byte frames. They're the same size as the pages. So the offset within each frame is going to match the offset within each page. So again, take a look at the letter P, for example. It is on page 3, offset 3, but then it's going to be in frame 2, but still will be at offset 3. So take a look at this in the book and read this section on addressing, and I have a lot of exercises for you. So let's try to find the logical address of the letter K. So if you try to look for the logical address of the letter K, what page is K on? K is on page 2, and the offset for K is also going to be 2. So it's going to be on page 2, offset 2. So that would be the logical address. So on the left is going to be the P, which stands for the page number, which is page 2. And on the right is going to be the D for displacement or offset within the page. Then the physical address of the letter K is going to be, you can look at the diagram here, the figure, or you can go to your page table and notice that page 2 is in frame 1. So the physical address of the letter K is going to be frame 1, and the offset is going to be the same, because the letter K, even if you took that page and you put it into frame 4, letter K is still going to be at that same offset. So you have to remember that the offset is always going to match, whether it's the page number or the frame number, the offset within the page or the frame is always going to be the same. So this is an example of a very simple example of using pages and put them into frames, and then doing a logical address to a physical address. And you can do it with looking at this with any letter just to practice. And you can see that the pages are put into frames and that any letter is going to be at the same offset within a particular page. So here we have an exercise, which I hope that I'm going to instruct you to try this exercise and then watch the video. So we have a 32-bit virtual address. That means your virtual address has 32 bits in it. That means you can do 2 to the 32. That's how many bytes you can have with 32 bits, 2 to the 32. You have 128 megabytes of main memory, which is 2 to the 27. And the page size is 4 kilobytes each, or 2 to the 12. So when you break your 32-bit virtual address into page number and offset within the page, you're going to also have to break your physical 27-bit physical address into frame number and offset within the frame. You need to decide how many bits will be used for the page number and the frame number, which is going to be the same. And if you look at the size of the page, that's how many bits you're going to use, the size of the page. You can have 2 to the 12, or which is around 4,000 bytes size pages, okay? And with a 32-bit virtual address, you can have how many pages of that size? 2 to the 20. You have 20 bits for your page number. So you have 2 to the 20 pages, all of size 2 to the 12. And how many frames can you have if you have 128 megabytes? You can have 2 to the 15 number of frames, all of size 2 to the 12. So once you read this first part and you break your virtual address down and you break your physical address down, then you can start to answer the question. So how many frames does the system contain? It's very common for people to say it has 15 frames. It does not have 15 frames. It has 2 to the 15 frames. So that's 32,000 frames in the system, or approximately. How many bits does the system use for displacement? So displacement is the size of the frame or the size of the page. So if you have 4 kilobyte size pages or 4 kilobyte size frames, the displacement is going to use 12 bits for that. And how many bits are used for the page number? 20 bits are used for the page number. You have 2 to the 20 number of pages, all of size 2 to the 12. And the virtual address, so here we have a virtual address and we want to check if it's in the TLB. So first you have to break your virtual address into page number and offset within the page. So if I draw a line right here, I can see that this is going to be page 5, and this is the offset. So yes, the page happens to be in frame 2, and yes, it is valid. So then the question says, what is the physical address? Well, the offset is going to be the same, but on the left side, you're going to represent the frame number and not the page number. So it's going to be frame 2 with the same offset as the logical address. And you would use 15 bits or 27 bits in total for your physical address and 32 bits in total for your logical address. Okay, thank you. That concludes our this video on address translation, and we will be doing more things with paging in the next video. Thank you.